So in this next phase, we're going to be incorporating some health components into there in the form of individuals going between health states. And this stuff is going to be fairly familiar in terms of its overall structure, but there's going to be a representation of environmental mediated transmission rather than transmission mediated by another person. Okay? So, yes, it's recording right now? Yeah. Oh, thank you. Thank you. Sorry. Okay. So, boom, boom. Oops. There we go. Okay. Okay, so ladies and gentlemen, what I'd like you to do is to go to person, and we are going to add in a second state chart to person. Okay? And this state chart will be focused on infection progression, whereas the first one is focused on mobility. I should note that this model I've been building is now available through the course website in the models built in class area. Okay, so you're welcome to download it. Okay, we want to go add in infection state chart, and this infection state chart, ladies and gentlemen, will have states susceptible, shedding, and recovered. Okay? Susceptible, shedding, and recovered. And whilst you do that, I'm just going to add in this video that we just created in case anyone wants to watch that. Okay, great. Okay, so ladies and gentlemen, infection state chart. So susceptible, shedding, and recovered. Now clearly we know how to do latent periods before. We've done it several times now, and you'd be welcome to put them in. I thought to spare us at the extra parameters, we'd probably not do that for this, but you can choose accordingly. We could also have someone who's a carrier, etc. There's all sorts of twists, but we're trying to take a look at environmentally mediated infection. So, ladies and gentlemen, we're going to have two transitions. One's between susceptible and shedding, and one's between shedding and recovered. Okay? Great. Okay. Now, for the shedding and recovered, there's going to be a mean recovery time. We could also call mean duration of shedding, but let's call it maybe mean recovery time, which we're going to locate in main. Okay, we want to be able to change it by experiment. So because we want to change it on an experiment by experiment basis, where does that parameter have to live? Main. In main. Yeah. Okay. So let's add this parameter into main. It's going to be called mean recovery time. Okay? So we're adding it into main. Ladies and gentlemen, what sort of type of parameter will that be? Time. It'll be a time parameter. Right. And we're going to specify it as 7 days. So we'll choose days and say 7. Okay? 7 days. Now, Kurt did verify a suspicion I had, which is that, well, it's nice to to do this, you're going to want to make sure anywhere you use this parameter, it uses the same units. It's not going to automatically convert nicely, so later you use it as if it's in hours and you state that and it converts it nicely. If only it did, but yes, Kurt?
You could change the name, say this.
Mean recovery time in days?
Yeah.
Yeah, I like that. I was hoping we would, if it automatically did it, we could avoid that, but now it is in days. It's part of the meaning. And Kurt's exactly right. Mean recovery time in days. So when you see 7, you know it's in days. Yeah.
Try to curry favor now and again by suggesting longer names. Usually it works.
I appreciate your aesthetic sense, Kurt. Developing aesthetic sense. Okay. Very good. So mean recovery time in days. Let's go back to person. And their transition from shedding to recovery will be a timeout mediated by mean recovery time in days. And we have to make sure, this is what I'm saying, we have to make sure that this is not in hours but in days, the thing next to it. Because by default, I think it uses the model's time unit. Okay. You folks okay? Okay. Now, ladies and gentlemen, it's this next transition, or this earlier one, to which we'll now apply ourselves. We should probably give a nice name to this transition. It's really good to give good names to things. It communicates better, makes you less confused when you're searching for something. You can find it more readily. This one from susceptible to shedding, this will be called, well, I'm going to call it environmental infection. Sorry. Environmental infection, this top one. We're going to show the name. It's nice to show the name so people can see it. And this one's going to be a rate transition, but currently we're going to give it a rate of zero per day rate, just 0. Okay, and there's a reason for that. We're going to come back and set that. Okay. Actually, let's do something though. I want to be able to test the model, so we're going to put this down like this, and we will mark it as being something we have to return to. May I show you something that can be quite useful to mark where to come back to? Okay. One thing you can do is you can put in a description. So sometimes I might put in the description something like star, 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 update this rate later. And then I might search for star, star, star with my convention in order to find places I have to do work. Another way you can do this is by putting in a Java comment that is similar, update later. This is another form of Java comment. You've already seen the // which just forms a comment on the current line. This forms a comment between a /* and a */. Everything between those, to wit, this area here, is a comment, and it will be ignored. Any logic will just ignore that. And so this provides a way of sort of marking something nicely. Or you could say, derived from Johnson and Smith, 2007 or something like that, which is kind of nice for metadata. But some of those you can put in the description quite nicely. Saving metadata with a model, like where parameter values were derived, can be very good practice, and the description is available for many constructs and provides a way of supplying that information readily. Okay? So I made this right now 0.1 per day, but I've marked this, update this rate later. Okay? Good, ladies and gentlemen. Okay, now, this is familiar territory. So right now it's a fixed rate, soon it won't be fixed. Now we want these people to change color. Okay? How are we going to have them change color? What are we going to add? Variable. Variable color. You know the trick. And it's good you know these tricks, because these are standard tricks, day in, day out, we use. So it's suitable that you're starting to master them. This can be black originally. Remember, it's a type other color, capital C. This denotes set of all possible colors, just like capital H homes denotes sort of a set of possible homes, home hood. This is sort of color hood. And then this is going to hold a particular color. At any one time, this is going to hold a specific color. Initially, it's going to start black, and then maybe it will change to what? Green, maybe, for susceptible. Color equals green. So when it goes through there, it will hold green, etc. And different people can have different colors at a given time. A class, ladies and gentlemen, like person, it's like a cookie cutter. It can produce many particular people. They all have behavior described by this class, but they differ in their particulars, the parameter values, what states they're in, etc. Okay? And they'll each have their own variable color. Okay. For shading, I'm going to make it red, and I'm going to have color equals red. And ladies and gentlemen, for recovered, I'm going to have color equals. Kurt, do you have a strong preference? Did you like magenta yesterday?
It's just visible.
Okay, we'll do, is this magenta? That's orchid. This one, okay, that's magenta. Okay, do magenta.
Visible. That's, I mean,
Yeah.
you could make the shedding
Yeah,
magenta, it's more visible than the red.
sure.
But
Okay, so color equals magenta. Good. Okay, now, is this going to be operational? What do we have to do to actually make that the color of the person? So we have a variable called color, but right now it could be called foobar. It has no impact on things. So what do we have to do to make it have an impact, to be operationalized?
Drawing to person presentation.
Yeah, so we go into that. Now, we could futz around with this, but I always like to go in this way. Presentation, person, shape, body. You could try to click on it, but it's finicky. Ladies and gentlemen, for shape body, I'd like to set the fill color to be color. There we go. Color. Okay? Are we okay? So, how do we do this? We went to person, in presentation, under person, shape body, and we set it so that the fill color, we scroll down to appearance, and we set the fill color to be color. Is that okay? Notice it says line color, no color, but fill color we've set to be color. Notice we had to do this, right? We had to do this thing to turn it dynamic. Okay, are we ready to run this? Who would like me to show something? So now we have two state charts. Let's rehearse, let's reflect on what that means. At a given time, a person will be in one state with respect to this state chart. They'll be in either off time or work time. And simultaneously, they will be in one of these states, susceptible, shedding, and recovered with respect to infection. So each of these has a certain, we call this a separation of concerns here, right? This deals with infection-related concerns, this deals with mobility concerns. Now, the two are not total solitudes. The two are not totally independent. You know, being in this state might affect things over here by accelerating infection. Maybe when someone's at work, there's a bigger pathogen load, and so it will tend to infect things. Or even this state could set a hazard rate that would be higher than this one that would apply to this transition. But it's very nice to parse out the set of states into different concerns. And I want to highlight, for those who have seen compartmental modeling, where you might have two conditions. Maybe it's Hep C and HIV. And you could have a stock and flow model in system dynamics, compartmental modeling, susceptible, infected, recovered, say. No recovery, unfortunately, with respect to HIV. But it might classify people within a given state as to what their status is with respect to each one. And you got to deal with all possible combinations of these possible states. You could be in one and other. For example, we have a model that I provided to you with HPV and smoking status. And the aggregate model analog to that agent-based model has to consider all possible combinations simultaneously. So you can be in this, HPV state A, and a non-smoker HPV state A, and a current smoker HPV state A, and a former smoker HPV state B, and a never smoker HPV state B, and a current smoker HPV state B, and a former smoker, and it gets very. It tends to blow up in terms of the combinatorics of it. There's a huge number of possible states, and it's very tedious. And it requires modifying across the entire model when you go to add a dimension of heterogeneity. Here, we don't have to deal with all possible entanglements of states, all possible combinations. We don't have this combinatorial problem. Instead, we have each state chart describing a particular type of concern, and we can have some interactions at a surgical level. But if we want to add a new type of concern, we can simply add a new state chart. We don't have to go back and mess with all the other state charts just because we're adding a new one. That's in contrast to what's needed with an aggregate model where we have to update it across the model as a whole. So the ability to take advantage of heterogeneity and multiple comorbidities is a compelling motivation for the use of individual-based modeling like this, okay? So now we have these two state charts. Great. So we've just added in color to affect a person's appearance. And now I would like to suggest to you, ladies and gentlemen, make a modest suggestion that we run this model. Okay, now the visual appearance is it's hard to make out here. Okay, I think I'm going to drag out my mouse. So pardon me while I get out my mouse. There we go. There we go. Okay, I think this is going to be easy with a mouse wheel. Okay, the dream of centuries. Okay. Okay, so here we go. Here we go. Look at that. What do we see there? What lies before us? Well, here's magenta. Okay, yes. So ladies and gentlemen, what we've seen is now people transitioning. Let me play that again. Okay. Okay, ready? Okay, here we go. We're playing it out. They're not yet. In fact, this one's infected. This one's infected. Playing it out more, and they're going back and forth. You could see them crossing here occasionally. Now both are infected, and then soon enough they'll be magentized to recover. Okay? So there's some dynamics going on. Fair enough, but we're not yet at the heart of the matter. We have dynamics for a person, but now we need to have the dynamics at the level of the environment. Okay. Okay. So I'm going to with an eye towards our colleagues. I'm going to save this.